Back to my YouTube channel. We're still under strength of material N6. So we'll be dealing with what we call propelled cantilever. The propelled cantilever is a cantilever that is subjected under a upwards force, whereby propelled, we know that talking about it's a propelled cantilever. What is that? It means that is subjected under what? A prop force. The prop force. A prop force can be, if you have a cantilever, any force that is acting downward, upwards. The force that is acting upwards, any can be it can be at any position. We call that the propelled wise. It's a propelled force. All right. So what is going on here? So we have the UDL, as you can see throughout. So obviously this UDL, at A, you'll simply have the force that will result because of the UDL. Remember, will be acting here at the end, will cause this to bend, the beam to bend. It will cause the beam to bend, this UDL. It will cause the beam to bend, isn't it? So the beam will try to bend like that, but as it is bending, there is some force that is applying there. The propelled force, it's opposing this bend, is trying to lift up this cantilever there. All right, there is a propelled force, but however, since this propelled force is affecting, it will cause an affection there. You see, they will cause, because there's a propelled force that is acting, it will cause a reaction that will take place there, right? And then that reaction that will take place at that point, we're supposed to subtract it, right? So that means the at B, the deflection at B must be equals to the deflection where the propelled is taking place, right? If you have the cantilever again like this, for an argument's sake, if you have a propelled that is acting here, you must know, if you have a force that, again, the weight or a point load that is acting, the propelled force must be equals to this. The propelled force must be equals to that, must be called where it's acting, the deflection. The deflection, or the, I mean, the deflection must be equal. The deflection must be equal. But if it's acting at the end, like this, the propelled force, let's say it's acting at the end like this, you have your propelled force is acting where, remember, it's acting upwards, but at the end, let's say for argument's sake, you have the force here that is acting down, or you have the force again that is acting. This propelled force will be the deflection the deflection for propelled force, or right, or the force of the propelled. We call it the force of the propelled, must be equals to the sum of this deflection that caused by this point load. The deflection that is caused by that point load there must be equal to the sum of those. If it's acting there, the sum of those, even if you have sum here, must be the sum of all of those. Doesn't matter if you have doesn't matter how much, must be the sum of those deflection of that point there. All right, hopefully you'll understand this. All right, so this is what we have there, and that will take place like that. So it says figure 4.10 shows a cantilever which is 10 meter in length. All right, is 10 meter in length and carries a uniform distributed load 2 kilonewton meter across the whole length. You see, then the beam has a propelled force F kilonewton at a point 2 away from the free hand. All right, so as they keep the beam from the puppet will be horizontal. Say calculate the volume of the puppet force. As you can see, that is what will take place there. So we'll have, if you can check from here, we have as you can check for the distributed load from this is for distributed. This will be caused by the distributed at the end. If you have the distributed throughout, if you have let me explain this thing. You might ask yourself now where this force is coming from. You should not ask yourself. Let's say you have a cantilever again, and I know I did not explain this, but you must know if you have given, if the distributed load is throughout the beam until the end, the force for the force of this distributed load will act at the end is for what of this UDL. This UDL will act at the end, so will cause this beam to bend like that. Will act way at the end. Will cause it to bend like that. Right. So, but when we have that type of nature, you will have something like, so you'll have the band. All right. So as you can see from here and from this side going this side, the beam is doing what? It's bending. So there's a deflection that is taking place there. Are we together? There's a deflection. Hope we are together. There's a deflection. You can see the deflection at A, from A until there. There's a deflection. It's just deflection due to the point low, due to UTL. Can say for UTL at the free hand, can just say you're looking at UTL, the deflection due to UTL. We can have that the deflection due to UTL. Obvious will take place at A. There we have what there at A. We know the deflection due to UTL is W L raised to the power of 3 length divided by 6 EI. Right. So W, do we have that is 20 kilonewton. Is 2 kilonewton. The paper is the same as 2 times 10 to the power of 3. We took it times now the length is from the end, because this distributed load is stretched, it is spread throughout all the cantilever. Obviously will be from there until there will be by what it's 8. There will be what 8. We have there our 8. That 8 it is raised to the power of 3. Are we together? We do raise, do we have, what is this? Is 10. Oh sorry, this is 10. 2 plus 8, so it's 10. Will be 10. So anyways, let me just say 10 raised to the power of 3. Obviously divide this by now by 6. And modulus of elasticity you are not given. Also this you are not given. So this is what we have. So we can punch this on your calculator like that. You'll obtain this to be equals to 333 comma will be 3 comma 3 times 10 to the power of 3 into EI. All right, this is what you have there. So obvious it's at the A due to UTL there at the A. So since there it's at the A, we are done with that. Remember, it won't, you are done with that. It won't have what the, it cannot have what the additional deflection, but the angle will be there. Always the angle anyways will be there if you want to calculate it. The angle there at what at A, there will be the angle this side. There is always what there is there is the angle there. If you want to calculate the angle at what, at point A, are we together there? So let's try and calculate that angle. If you want the slope, and what I'm talking to, there will be W L cubed divided by H E. No, cannot be big, must be small. It's an angle, must be 6 multiplied by EI. So this slope will be the slope where the slope here at A, we can have the slope at A, whereby we know we'll have this is 2 times 10 to the power of 3 multiplied by the length is still times 10 to the power of 3 throughout the length divided by 6 EI. All right, because we have the obviously the angle will have, remember the angle, you measure it from where it's horizontally like that, then where it has bended like this, then this will be the angle. Then the deflection is from the original beam going where it has bended. This is a deflection, but the angle obviously it will have the angle here at the way at the end, either way, that is our theta. So the at A, so if you are wise, you're supposed to see that, then this can multiply this like that. Therefore the angle there, the slope at A, must be equals to what? To 2,5 times 10 to the power of 6 divided by EI. Alright, this is what we have. Then the slope, we were done with this part. Anyway, now let us go to this point. I've said if you have the UTL, that is, if it is trenched to out like this, if you have the UTL, I've just shown you there, if it is straight to out like this, if I have maybe here the prop is acting there, there will be some force that will act in the opposite direction. There will be some additional force that will act in the direction exactly there, that will act exact in the direction. Alright, but due to this UTL, it has its weight to remember. So the UTL will try to go down. Also, the prop chap will try to go up. You must know that. So here you must know there. You must know there, since let me just show, since here there is this prop shaft here, there will be some additional force due to UTL that will want to opposite that. Obviously this will still bend a little bit, still have that, so there will be that is trying to do like that. So as you can see, we cannot use this until the no, that here I said will be an additional, will be just an additional what, an additional, this will be just an additional force. That means we'll have to, this additional force, since we have the UTL, we have to multiply this by what, by 2. Since we have the slope, the additional will be additional, will multiply by 2. Remember that it's an additional, you'll multiply by that 2, like additional. We'll go from there until there, you know, I've explained that the additional will act in that direction, that additional band there. So sort of like a additional, we'll have the deflection, we'll have that is a deflection, but it's sort of like additional. I know it's an additional, right? You must understand that. So but that additional is acting where, here at B, isn't it? That point there on top for due to UTL at B. I like to call this additional UTL. So we'll have, obviously, how cookie crumbles. The additional must be as you know, that must be equals to the slope multiplied by the force, the one that we have, the deflection, the exact multiply the slope multiplied by the additional length. So remember, this will due to UTL. So the slope of UTL, I think we did calculate the slope. Here it's our slope, isn't it? For UTL is for UTL, even though it's at point B, but it's for the UTL. You cannot just calculate for in there. You cannot just calculate any that one. Any, yeah, we think we let me see. This is incorrect. Sorry. This is incorrect a little bit. So this value here is supposed to be 2.5 times 10 to the power of 6 over EI. Then here we're supposed to have 3 times 10 to the positive 6 divided by EI. So this is our slope then. So this slope, as you can see there, it was 3 divided by times 10 to the power of 3 EI times E multiplied by I, modulus of elasticity. Now the additional multiplied by this additional length, will be 2. Is this from that side? It's an additional, is what is 2. 2 will be multiplied by that 2. So there we'll have this will be equals to 6 obviously times 10 to the power of 3 divided by EI. So we have this deflection at B, exactly B. But okay, now we have this deflection at B. As you can see, you have now this deflection. But as you can check, we did calculate it. But now, as you check, since we have this deflection, called or just due to that force, the deflection will have the weight due to that force, due to this force, the deflection due to that weight there, to that point, due to that UTL at B, and then due to the prop. As you can see, they're acting in the opposite direction. You minus them because they're acting in the opposite direction. Let's minus those things there. So let's find the deflection at B. Let's find the total one. We're supposed to subtract these things now. So we subtract those things, but they must be equal because they're acting in the opposite direction. So those are not deflect. These will be a prop. So what will be this will be equals to what? Will be equals what? This will be equals to what now? They will subtract because we have to subtract the original one. We have to you take this one. When you subtract the deflection, you'll subtract to the original one. But this one, they will be equal. They're acting in this direction. The deflection there at B must be equal to the prop force there. So it's a prop force, but the total deflection at B, if you want it at B, if you have this UTL you must be equals to what? To the prop shaft. Must be equals to the, not the prop shaft, what I'm trying to say, must be equals to, at B must be equals to the deflection, the total deflection here at A for this whole beam, this from that for this whole beam minus the deflection that you had for W, the at B, the deflection there at B, the deflection at B. So I hope you'll understand what I'm trying to say. I mean, let's say now you have the force. I'm just making an example here. Let me call it D. How will you find the total there, the total deflection at D? The total deflection at D must be equals to the deflection here at A for this whole beam, the deflection at A minus the deflection at B. Understand? Let me say here, I just call it C. Here we have the, do you understand? You have the point there, C. That must be the deflection at C minus the deflection at A of this beam minus the deflection at what? At C. Remember, this is the total deflection. This is how you get. Hopefully you'll understand this. So that is what we'll have there. So the total deflection at B, the total one must be the deflection obvious of A minus the deflection of B. Together it was here 2.5 times 10 to the power of 6 divided by EI. Now here we have to subtract the deflection at B. We know there is the one of 666,6 times 10 to the power of 3 divided by EI. Mathematically, you know, when you have the same denominator, you simply focus on the top part. You'll subtract those. This will be same as 2.5 times 10 to the power of 6 minus 666,6 times 10 to the power of 3. You only take one denominator. This is just the maths. So simply punch this there on the calculator. You'll have 1,833 times 10 to the power of positive 6 divided now by EI. So this is what you have so far. This is a total deflection at what? At B. But I've said now the total deflection at B must be equals to the prop there. Now we have this total deflection at B. The total deflection, the total one, now must be equals to what? To this prop. They're acting in the same direction. Must be equals to the prop. To the prop. You understand what is the prop there? You are to get must be equals to the prop. I don't know that you know the prop force. So the deflection at B must be equals to the prop force, or the whatever prop deflection or prop force, or let me just say prop deflection prop deflection prop, because here we'll have weight, isn't it, multiplied by L3 divided by 3 EAI, but here won't be W. This won't be of the distributed, will be force, prop force multiplied by L there, multiplied by L divided by 3AI divided by L raised to the power of 3, where is 3 like that. Oh, I'm writing, so it's writing like that. F prop multiplied by L 3 E I. All right.